question number 21. They have given you Fn is alpha to the power n, beta to the power n, and they have said three 1 plus f1, 1 plus f2. So let me just write it, because you people have the question paper, so no need of writing this. Let me just write the actual value. F1 will give you what? Alpha plus beta. In this case, it will be 1 plus, we have F2. So it is alpha square plus beta square. And then we are having 1 plus F1, which is 1 plus alpha plus beta here. Then we are having 1 plus F2, that is 1 plus alpha square plus beta square. 1 plus alpha cube plus beta cube. Then again 1 plus alpha square plus beta square, 1 plus alpha cube plus beta cube, 1 plus f4 means alpha to the power 4 plus beta to the power 4, and that they have given us like k times 1 minus alpha whole square, 1 minus beta whole square, and alpha minus beta whole square, and they have said to find out the value of k. Then k is equals to the 4 options are given to us. Now you observe carefully. I'm writing this determinant as a product of two determinants. Product of two determinants. I'm writing this determinant as a product of two determinants. So it's 1, 1, 1. So if I multiply this, 1 plus 1 plus 1, that gives you 3. So we got the first element. For the second element, what we are doing, we are writing it here as 1, then alpha, then beta. Is it clear? Now if you multiply, what we will get? 1 plus alpha plus beta. Is it clear? In this case, we are getting 1 plus alpha square plus beta square. So what we will do, I'm writing it as here as 1 alpha square here, beta square here. Is it clear? Now if you multiply with this row, then this row and this row, we are going to get these three elements. Is it clear to all of you? Now, to get this element, 1 alpha, 1 plus alpha plus beta, here it is 1, 1, 1, so it has 1 alpha and beta. Is it clear? Now let us check whether this part and this part are coming or not. If this row is multiplied with this, we are getting 1 plus alpha square plus beta square, which is exactly there. And when this is multiplied with this, we are going to get 1 plus alpha cube plus beta cube, which is exactly there. Is it clear? Now for the third row, we are writing it here as 1 alpha square beta square, because we have to find out 1 plus alpha square plus beta square as the first element of the third row. So when this row is multiplied with 1, 1, 1, we are definitely going to get 1 plus alpha square plus beta square. Now let us verify whether the other two elements are coming or not. 1 alpha cube plus beta cube. So we got it. Now with the third row, 1 plus alpha to the power 4 plus beta to the power 4. Exactly what we got. Is it clear? Now, in determinant, you all know that if it is this determinant, if we expand, we are going to get x minus y, y minus z, z minus x. Okay? So we are going to get this result when we expand this determinant. So in this case, you observe carefully, this part will give you, this is exactly same as that. Here x is nothing but 1, y is alpha and z is beta. So what we are going to get from here? 1 minus alpha, 1 minus beta, and alpha minus beta, right? For the first determinant. And for the second determinant, we are exactly going to get the same thing. So it will be nothing but 1 minus alpha square into 1 minus beta square into alpha minus beta whole square. Now what we got here? They have already given this is nothing but your k times 1 minus alpha whole square, 1 minus beta whole square, alpha minus beta whole square, right? So if we compare, we are going to get k as 1. Therefore, our option C is correct. Option C is correct for question number 21. Have you understood this problem clearly? Now in question number 22, they have asked us to find out the period. Remember one thing, if the function fx has its fundamental period as t, then sine of fx will also have the period t. Is it clear? Similarly, tan of fx will also have the period t. Is it clear? Now for the first expression of the given function, which is our sine cos x by 2. Now what is the period of cos x by 2? It is nothing but 2 pi divided by half, which will give you 4 pi. Is it clear? Therefore the period of sine cos x by 2 is 4 pi. And for the second expression, which is our cos sine x. Now this is very important. See, cos sine x, the period of sine x is 2 pi, therefore its period will be 2 pi. Is it clear? But this is not correct. Remember, because you see, what was the definition of period? If the function f of x plus t is equals to fx, then the least value of t, that is the fundamental period, that will be the period of that function. Period means we are always talking about the fundamental period. So the fundamental period of that function will be t, where t is the least value among those periods. Okay, now you see in this case 2 pi is a period of this function, that's for sure. But 2 pi is not the fundamental period, because you observe, if my, let us say this function as gx as cos sine x. Now if I put in place of x as x plus pi, so what we are going to get? Cos sine pi plus x. Okay, sine pi plus x will give you minus sine x, but this cos will absorb this minus sine. So it will give you again cos of sine x. Am I correct? Which is nothing but your fx. Therefore, the fundamental period of cos sine x, that is what we termed as the period of that function, is nothing but your pi. Therefore, the period of this function is nothing but cos sine x is nothing but pi. Okay? Therefore, the period of fx is nothing but LCM of 4 pi and pi, which gives you 4 pi itself. Is it clear? Therefore, the period of the function fx is 4 pi, and our option D is correct for question number 22. Is it clear to all of you? In question number 23, they have given A and B are two matrices such that A B transpose plus A transpose B, B A transpose is null matrix, and they have given you A is a skew symmetric matrix. That is, A transpose is nothing but minus A. Now we have to check your matrix BA. So let me just take transpose, which can be written as A transpose B transpose. Again, A transpose is nothing but minus A. So it's minus A B transpose, which gives you minus A B transpose. Is it clear? Now A B transpose minus A B transpose is nothing but B A transpose. Is it clear? Now A transpose again can be replaced by minus A, so we are getting it is as BA, minus of BA. Is it clear? So we got BA transpose is nothing but minus BA, hence we can say that BA is a skew symmetric matrix. It's a skew symmetric matrix. Is it clear? Therefore our option B is correct. Option B is correct for question number 23. Is it clear? In question number 24, they have given cos A plus cos B plus 2 cos C is equals to 2. Okay? Now A, B, C are basically the capital A, capital B, capital C. These are all the angles of the triangle ABC. Now we have to find that the sides of the triangle ABC are in, and the four options are AP, GP, HP, or none of this. Okay, so let us start the sum. Cos A plus cos B can be written as 2 minus 2 cos C. Cos C plus cos D formula I am applying. 2 cos A plus B by 2, cos A minus B by 2, and in the right hand side if I take 2 common, so it is 1 minus cos C, which is nothing but your 2 sin square C by 2. 2 goes off. Now you observe cos A plus B plus C. We know that A plus B plus C 180 degrees. So in this case it will be pi by 2 minus C by 2. Is it clear? So what we are getting here, cos 90 minus theta is sin C by 2, 1 sin C by 2 and sin C by 2. 1 sin C by 2 from the right hand side will get cancelled. So we are left with sin C by 2. Again, this C by 2 can be replaced by pi by 2 minus A plus B by 2, which is nothing but your 2 cos A plus D by 2. Now let me just take this cos A plus B by 2 in the denominator. So we are getting cos A minus B by 2 by cos A plus B by 2, which is nothing but your 2 by 1. Now if we apply componendo and dividendo, so what we are getting? Cos A minus B by 2 which is equals to, which is nothing but your 3. Is it clear? Now in this case what we can write, if we apply cos C plus cos D formula, so we are getting 2 cos C plus D by 2, cos C minus D by 2 divided by, again cos C minus cos D formula we are applying, 2 sin C plus D by 2 sin D minus C by 2, which is equal to 3, right? Now this will give you what? Cot A by 2, cot B by 2, which is equals to 3, right? Now you see, cot A by 2 can be written as what? S into S minus A divided by del into, for cot B by 2 we can write S into S minus B divided by del, which is equals to 3. So what we are getting? Del square. Del square is what? Del square can be written as S into S minus A into S minus B into S minus C, which is equals to 3. S goes off, S minus A, S minus A, S minus B, S minus B. So we are left with S by S minus C is 3. So that implies S is 3S minus 3C gives you 2S equals to 3C, right? Now 2S is nothing but A plus B plus C. S is the semi-perimeter. So 2S is nothing but A plus B plus C, which is equals to 3C 2C. Is it clear? A plus B is nothing but 2C. Therefore, we will say that the sides A, B, C are in AP. Therefore, your option A is correct for question number 24. Your option A is correct for question number 24. Is it clear to all of you? In question number 25, they have given that for a triangle ABC, 2 cos A by A plus cos B by B plus 2 cos C by C equals to A by BC plus B by CA. Now we have to find out the angle of this triangle. That is, you have to find out any one angle of this triangle, right? And that angle will be pi by 8, pi by 4, pi by 3 or pi by 2. These 4 options are given to us. So here what we are doing, we are applying the cosine rule for cos A, cosine rule for cos A, cos B as well as cos C. So see what we are getting. In the right hand side, we are taking the LCM as ABC. So we are getting A square plus B square divided by ABC. In the left hand side also, we are taking the LCM to ABC. So what we are going to get here? ABC goes off. So we are left with what? Which is equals to 2A square plus 2B square. So that implies what? B square plus C square equals to A square. Is it clear? Therefore, since A square equals to B square plus C square, hence we will say that the triangle is a right angle triangle at A. Is it clear? Therefore, the triangle will be a right angle triangle. Hence, our option D is correct for this question number 25. Is it clear to all of you? In question number 26, they have given us the relation x sine theta equals to y sine theta plus 2 pi by 3 equals to z sine theta plus 4 pi by 3, and they have asked us to find out the relationship between x, y and z. So 4 options are given to us. So let me take the relation which is given to us as k. So we can write k by x as sine theta, k by y as sine theta plus 2 pi by 3, and k by z is nothing but sine theta plus 4 pi by 3, right? So now what I'm doing is I'm adding the corresponding sides of these 3 equations that we got right now. So what we are getting in the right hand side? Sine theta plus 2 pi by 3 plus sine theta plus 4 pi by 3. Is it clear to all of you? Now, find the formula sine C plus sine D. So what we are getting? 2 sine C plus D by 2, 2 sine C plus D by 2. So you will get pi cos C minus D by 2 will give you pi by 3. Okay? So we are getting sine theta minus 2 sine theta into cos 60 degrees half. So we are getting basically sine theta minus sine theta, which gives you 0. Is it clear? Now in the left hand side, if I take k common, so we are getting 1 by x plus 1 by y plus 1 by z as 0. That implies if I take the LCM, so we are going to get xyz, xy plus yz plus zx equals to 0. That implies xy plus yz plus zx equals to 0. Is it clear to all of you? Therefore, option B is correct for question number 26. Therefore, option B is correct for question number 26. Have you understood this problem? Now, in question number 27, they have given us that cot x minus cos x equals to 1 minus cot x into cos x. There is a little printing mistake over here. It will be not be theta. It will be actually x, right? Your x is lying from 0 to 2 pi. So the question is, find the number of values of x which is lying from 0 to 2 pi which will satisfy this equation. That is the question. Have you understood? There was a little printing mistake. Theta was given there, but it is not theta, it is x. It is understandable. Now, from the given equation, I am simplifying it. Just see. So we are getting what? After taking the LCM, now in this part we must remember that since sin x is in the denominator, your sin x cannot be equals to 0. That implies your x cannot be equals to n pi. So be careful about it. So now I'm cancelling this. So what we are getting? I'm taking everything in the left hand side. Sin x plus cos x common. So we are getting cos x minus sin x, which is equal to 0. That implies therefore either cos x minus sin x is equals to 0 or cos x will be equals to minus 1. Okay? Now if cos x equals to minus 1, tell me where cos x becomes minus 1. Cos x becomes minus 1 at x equals to, in this region, x equals to, when x equals to pi. Is it clear? When x equals to pi in this region, your cos x is minus 1. But x cannot be equals to pi. Why? Because we have already said that x cannot be equals to n pi. Therefore, this value is rejected. So from here we are getting tan x as 1. That implies x will be equals to, what are the values where tan x equals to 1 in this region? When x is nothing but pi by 4. As well as 3 pi by 4. Am I correct? Therefore, there are two values of x like pi by 4 and 3 pi by 4 for which this equation will be satisfied. Therefore, they have asked you to find out the number of values of x. Therefore, how many number of values of x? Two values of x, right? Therefore, our option B is correct for question number 27. Is it clear to all of you? Absolutely. In question number 28, they have given tan alpha is x square minus x by x square minus x plus 1 and tan beta as 1 by 2x square minus 2x plus 1, where they have said that x is not equals to 0 and 1 and alpha beta are lying between 0 and pi by 2. Then they have asked us to find out the value of tan alpha plus beta, and the four options are given as 1, minus 1, 2, 3 by 4. Now let me start the sum from here. Which can be written as 1 by tan beta. So x square minus x is nothing but 1 minus tan beta divided by 2 tan beta, right? Now we have been given that tan alpha is x square minus x by x square minus x plus 1. So in place of x square minus x, I am replacing by 1 minus tan beta by 2 tan beta. 1 minus tan beta divided by 2 tan beta divided by 1 minus tan beta divided by 2 tan beta plus 1. So if we simplify, we are going to get 1 minus tan beta divided by 1 plus tan beta. Is it clear? Now let me cross multiply. So what we are getting, let me take tan beta in the left hand side and let me take tan alpha tan beta in the right hand side. So we are getting 1 minus tan alpha tan beta. Now if I divide it, we are getting tan alpha plus beta divided by 1 minus tan alpha tan beta, which is equals to 1. Now tan alpha plus tan beta divided by 1 minus tan alpha tan beta is nothing but your tan alpha plus beta. So tan alpha plus beta is nothing but 1. Therefore, our option A is correct for question number 28. Is it clear to all of you? In question number 29, they have given us that x equals to 1 minus x plus x square minus x cube, and this thing goes on till infinity. Right? Now we can see that the right hand side of this equation is a GP series, infinite GP series, whose common ratio is minus x. So what we can write, if we apply the infinite GP series summation formula, then we get it is nothing but 1 by 1 plus x. But here we must remember that mod of x is less than 1. That is, x is lying between minus 1 and 1. Is it clear? Now if we cross multiply, we are going to get, so that implies, now if we solve it, we are going to get, by applying Sridhar Acharya's method, minus 1 plus minus under root b square minus 4ac divided by twice a. So we are getting basically what? Minus 1 plus minus root 5 divided by 2. Now in this case, we will take the value of x as root 5 minus 1 divided by 2, rejecting the value minus 1 minus root 5 by 2, because in that case your x will not lie between minus 1 and 1. If we take x equals to minus 1 minus root 5 by 2, then it will be less than minus 1. That is, it is not falling between minus 1 and 1. Therefore, we can write root 5 minus 1 by 2 can be written as 2 times root 5 minus 1 by 4, and the value of this is nothing but sine 18 degree, right? Sine 18 degree is root 5 minus 1 divided by 4. So it is 2 sine 18 degrees, right? Therefore, x is 2 sine 18 degree. That gives you the option C. C is the correct option for question number 29. Is it clear to all of you? In question number 30, they have asked us to find out the range of the function where fx equals to x square plus x plus 2 divided by x square plus x plus 1. Where they have said that x belongs to any real value. Is it clear to all of you? Now what I'm doing here is, I'm writing x square plus x plus 2 by x square plus x plus 1 as 1 plus 1 by x square plus x plus 1. Is it clear? Now you observe that x square plus x plus 1 is always greater than 0 for all x belongs to any real value, and its minimum value will be minus d by 4a. Remember that? If you have not remembered this, please, I will refer to go for theory of quadratic equation section and see that one. When the parabola opens upward, then we always get the minimum value, and the minimum value will be minus d by 4a, and the minimum value takes place at x equals to minus b by 2a. So this thing can be written as what? Minus d means the discriminant b square minus 4ac divided by twice a. Okay, b square minus 4ac, that is 1 minus 4, and divided by 4a. So 4a will give you 4 only. So you are getting 3 by 4. So that is the minimum value of the expression x square plus x plus 1. This is the minimum value. If this is the minimum value, then the function fx will have its maximum value at, what will be the maximum value? The maximum value will be 1 plus 1 by 3 by 4, which gives you 7 by 3. Is it clear to all of you? This is the minimum value that takes place at x equals to minus b by 2a. That is the conception of which I have given in the theory of quadratic equation. So this is the minimum value, and the minimum value is 3 by 4. So at 3 by 4 fx will have maximum value, and the maximum value is 7 by 3. Now you see, what is the maximum value of x square plus x plus 1? X square plus x plus 1, the maximum value will tend towards infinity. Okay, the maximum value will tend towards infinity. If it tends towards infinity, then your fx is tending towards its minimum value at 1 plus 1 by infinity. It gives you 1 plus 0, which is nothing but 1. Therefore, the minimum value of the function is approaching towards 1, and the maximum value of the function is 7 by 3. Therefore, the range of the function fx is nothing but open 1, 7 by 3, closed. Is it clear to all of you? Therefore, our option C is correct for question number 30. Is it clear to all of you?